All right, so we're going to start 8.2, the reciprocal function family. And so the first thing that we're going to do is we're going to graph the reciprocal parent function. Okay, so the first thing we're going to do is we're going to grab our calculators, go to y equals. Make sure it's clear. And in y1, you're going to type 1 over x. And then go to your graph. So after you've looked at your graph, you're going to go to your table. So what I want you to do is I want you to start with x being -4. We're going to go all the way down to +4. So -4 will go -2, -1, -1/2, 0, and then we'll do the positives. 1/2, 1, 2, 4. So if we put our y values here, we'll see that when x is equal to -4, y is equal to -1/4. When x is equal to -2, y is equal to -1/2. Okay, so if we keep going, we'll see that -1, our y value is -1. -1/2 is not on our table, but I'll tell you that the y value is -2. And then at 0, we have an error. We'll get to y in just a minute. And then you'll see that the y values for the positive versions of those x are the same, but just positive. So it'll be 2, 1, 1/2, and 1/4. Okay, so I actually want to plot these points. I'm going to plot -4, -1/4. Now, one block is one whole space, so we're basically just going to try to go 1/4 of a block down. I'll show you how we're going to do that. We'll go to the left 4, and then I'll just plot my point like right there to try to get that 1/4. So it's kind of a guesstimation. Is everybody okay with that? And then I'll plot -2, -1/2. So I'll go halfway down the block. I'll plot -1, -1. I'll plot -1/2, so I'll go halfway left, -2. Then we'll plot the remaining points. So we'll go 1/2, 2, 1, 1, 2, 1/2, and 4, 1/4. So go ahead and plot the remaining 4. Okay, so as you'll see, this is creating a similar shape to what we're seeing on our graph. So I'm just going to roughly connect these dots to look something like that. And you'll notice that there is an error at 0 because we can't divide by 0, and x is on our denominator. So that's why there's an error at 0. Now we're going to talk about this graph in terms of its domain, range, vertical asymptote, and horizontal asymptote. So remember, domain is our restriction on our x. So our domain, look, you can see that the arrow is pointing to the left, essentially forever, and to the right, essentially forever. So our domain should be all real numbers except which one? Except what?
0.
Yes. So this is one way to write all real when you're low on space. So it's basically like a double columned R. I just write 2 vertical lines and then make my R on the second one, basically.
I was finna write my name.
And then we're going to say except x cannot equal 0. Now, because of our error, we also are going to look at the range. And if you notice, this arrow points up seemingly forever. Arrow points down seemingly forever. So our range is going to be all real numbers, except what? Except 0. Except where y cannot equal 0. So you'll notice here that these values get closer and closer and closer to 0, but they never reach 0, correct? That's what we call an asymptote. Values get closer and closer and closer to that line, that imaginary line, but they never touch it. So when we talk about our vertical asymptote, that goes up and down, right? Our vertical asymptote is going to be where x equals 0. So that would be this imaginary line right here. Our horizontal asymptote is where y equals 0. So we'll write y equals 0. So what we're going to do is, in our calculator for number 1, we're going to leave y1 as 1 over x. But in y2, we're going to type 3 over x. So go ahead, go to your calculator, and in y2, type 3 divided by x. And then go to your graph. And here, if we look at our graph, we can see that the red function, or the y2, was stretched by a factor of 3. Now I want you to go into your calculator, change y1 to negative 1 over x. So go to y1, we're going to delete y2. And I want this one to be negative 1 over x, and then I'm going to graph it. If I do this, in my graph, you'll see that there was a reflection across the x-axis.
So clear y2 out, right?
So for number 3 here, you're going to go back to your y equals. We want y1 to be 1 over x, so delete that negative. We want y2 to be 1 over x plus 2. Now, if you're not typing this as a fraction, you need to put the 1 over x in parentheses. And then put the plus 2 outside. When we go to graph that, you'll see the blue is the parent function, and the red is the transformed function. And we actually had that transform function, it shifted up 2 units. So that 2 outside of our fraction shifts our graph up. We've done this in all of our other functions, right? Stretch or compress, shift up or down, shift left or right. So we just have to figure out which numbers do what. And so you can probably guess what's going to happen on number 4 if I move that plus 2 from the outside of the fraction to the inside. What do you think is going to happen on number 4? Nope. So up and down is outside of the fraction. When we put it inside the fraction, we're going to move left to right.
It's going to move to the left.
It's going to move to the left. Yeah. Okay, so we can go back to our y equals, and we can change this to 1 divided by, and then you want the x plus 2 to be in parentheses. When we do that, you'll see that our red function actually moves to the left too. Okay, you'll notice on page 2 that I have all of these transformations laid out for you. So if you're ever confused as to what these might be, you can go back here and you can confirm what you're thinking. But we are going to work examples 1 through 3, where we are going to have to actually talk about multiple transformations as well as the domain, range, and any asymptotes they might have. Okay? So here on number 1, we have y equals 1 over x plus 1 minus 2. Feel free to type that into your calculator if you like, but we can also do this without our calculator. So that plus 1 is going to move us left. So we can say shifts left 1 unit. And what does the minus 2 do? Shifts it, no, the 2 is outside, so it's going to shift it down. Exactly. Okay. Now, let's talk about the vertical asymptote, the horizontal asymptote, the domain, and range. The vertical asymptote is always going to be at x equals h. And so in this instance, h is equal to -1. The horizontal asymptote is always going to be y is equal to k. So in this case, y is equal to -2. Now our domain is going to be all real numbers except, and before it was except where x equals 0, but here it changes to x cannot equal -1. So notice it's that value for h, just like the vertical asymptote. Now the range is going to have a new restriction too, all real numbers except y cannot equal, what do you think that value is? -2, exactly. Now because our asymptotes are no longer 0, we can find our x-intercept and y-intercept. We can do that in the calculator if you're ever asked on a math Excel, but we're going to skip that here. So I'm going to do number 2 with you, and then I'm going to let you try number 3 on your own. Ready for number 2? Okay, since number 2 just has that value of 5 on the numerator, that is our a. So we are going to say our function is stretched by a factor of 5. Now there's no h or k in this situation, so we have no change to left, right, up, or down. That means that our asymptotes and our domain and range stay the same as our parent function. So our vertical asymptote, x is equal to 0. Horizontal asymptote, y is equal to 0. Domain, all real numbers except x cannot equal 0. Range, all real numbers except y cannot equal 0. So when you only stretch or compress, the asymptotes and the domain range stay the same as the parent function. Okay, so I want you to stop here, try number 3 on your own. So going over number 3, the 2 that is in our numerator will cause a stretch. So we will say we are stretched by a factor of 3. The x minus 3, that minus 3 will move us 3 units right. And the plus 4 will move us 4 units up. So that means our vertical asymptote that correlates with our left to right movement is going to be x equals 3. Our domain,
Why are you letting me do this wrong?
I'm not,
Yes, I did.
will be all real numbers except x cannot equal 3.
Yeah, 'cause I put
I wrote that wrong, I'm sorry.
stretched by 2 units and right 3 units.
Stretched by a factor of 2, translated 3 units right. So I got that wrong. Thank you for catching that. All right, and then our horizontal asymptote is affected by our k, so its y is equal to 4. Our range, all real numbers, but y cannot equal 4. And that should be all.